welcome to Khetz Tutorials, and welcome to the next video in the Python for Beginners series. The previous video, we talked about arithmetic operators, and we have all of them, or the ones that we actually covered in the video, in the comments up here. So this is where we left off last time. Now, I have a question for you. If I set a variable x to 5, and I want to use the same variable in an operation, let's say I want to add 2 to this 5, how would I do that? Would I then say that x equals 5 plus 2 again, which is basically redefining this? What if I want to add 15 after this? Would I then say this? Then the result of whatever this is, it will not be 7. So 5 plus 2 plus 15. Now, this is a very long way to deal with this. Basically, what I'm asking is, how can I add values to x and assign the new result to x? This definitely is not it. And this is where assignment operators come in. With assignment operators, you can say x equal to x plus anything that you want to add to it. Let's say you want to add 2, like in the first example. In mathematics, or in normal mathematics, you can't do this, right? Because this is like, if you take this to that side, it's x minus x equals 2, which doesn't make sense. But in programming languages, you actually can do this. So if you want to add a value to x, you can say x will be x plus whatever it is that you want to add. Even if you want to subtract a value from x, you can do that. But once again, this is quite long to do. So as an example, let me just do this again as an example. Let's say you have x equals 5. Now, if you want to add 2 to this, you don't have to redefine this. Here's one option that you can do. And the answer here, if you print over there, if you print x, the answer should be 7. So it took the initial 5 that you set it to, and it added 2 to it. Then the result of that, which is 7, was now taken back to x. Now x was set to 7. So there's a short way that you can actually do this, and that is where today's video comes in. Today we're going to talk about assignment operators. So let's create a new file. You can call it assignment.py. Now, the first operator that we're going to talk about is indeed the assignment operator itself, or the equal sign. So the equal sign, that's what we're going to talk about first. And this is when you assign, or this is when you set a variable. We used x in the previous example. Let's continue using x. So now you have x equals 5, and this is an operator. This itself is an operator. Even though we have been using it for quite some time, it also is an operator. So we're saying x contains the value 5. That is what that means. Now let's get into the new operators that we might not have seen. And the first one will be when you're adding, just like when we're dealing with arithmetic operators. But if we want to add 2 to x, as I said, here's one option. This is what you can do. And let's just confirm that this actually does what we expect it to do. So, as I said, we expect this to say, okay, I'm going to take that 5, going to put it into x. It's already that. Then I'm going to say 5 plus 2. The result of this, which is 7, will be taken back to x. And now, when I print x, expect it to print 7. Because up here, I actually said the initial x plus 2. So as I said, in programming languages, you can do this. This is valid. So let's see the result, and let's see if it indeed is 7. So we're just going to run that. So it's running, taking quite some time, but let's be patient. Okay, so there you have it. The result is indeed 7. But this is too long, or it looks redundant. Or if you look at it in terms of mathematical standpoint, it doesn't quite make sense. So this is valid. You can do this, or you can use the shorthand or the shortcut, which is this operator. So you're going to put a plus, an equal to, and whatever it is that you want to add to the initial variable. So here's what's happening. X was 5. And we said if we want to add 2 to x, this is what we can do. This is a shortcut. We're saying add 2 to x and assign the result back to x. So if you want to talk about operands, these are operands. So the values that you work with are operands. We are operating on these things. So the right operand is added to the left operand, and the result is assigned to the left operand. And that is why this constitutes, or this falls under assignment operators. It has that equal sign as well, because after doing the operation or after doing the addition, we're going to assign our result to whatever's on the left hand side. So this is when you're adding. And the same applies for all of those arithmetic operators that we talked about. So next we can talk about subtraction. So we can talk about subtraction next. And we can change the value of x if we want, or we can keep it as it is. So let's keep it as it is. And with subtraction, you're just going to put the negative or that subtraction sign as well as your assignment operator to say that what we're doing is we're subtracting 2 from x. Then we're assigning the result back to x. So what do you expect? We're basically saying 5 subtract 2. This is what this means. So 5 subtract 2, expect 3 as our result, and that is what you have over there. The same applies for multiplication. So the next one will be multiplication. And we're just going to put the multiplication operator as well as the assignment operator, the equal sign, to say that this left-hand operand will be multiplied by the operand on the right-hand side. The result will be assigned back to the left-hand side. So that is how you can always read this. So the left operand and the right operand perform this operation, and the result is assigned to the left operand. So this x was 5, and this is equivalent once again. So this is equivalent. You can always view this like this. X equals x multiplied by 2. You can also write it like this if you want. But now in this video, we're covering these shorthand assignment operators. So that is why we do not go for this option. This is also valid. So now, if you look at that, 5 multiplied by 2, then assign the result of 5 multiplied by 2 back to x. When we print x, that is exactly what we get, which is 10. That is what we expected. The same applies once again for division. And just as a note, if you operate on x, then proceed to operate on x again, which is what we're going to do right now. This won't operate on the original value of x, but it will operate on the current value of x. So after this statement, Python reads from the top to the bottom. So after this statement, the value of x is not 5, it's 10. So if you divide 10 by 2, you expect x to now be 5. So if you didn't have this statement, it would operate on the original value of x because there's nothing in between this and that. But now, if we leave this back there, this then means that the value of x is changed, and this will operate on the new value of x. So keep an eye on that. The value of x isn't the original, but the value of x at that point. So the reason why we got 10 when we multiply over there is because the value of x at this point was 5, but now the value of x at this point is now 10. So this is an inverse of multiplication. So this is like saying x equals 10, x divided by 2 back to the original. So that is what we expect as our output. If I clear the terminal and I run this, we'll have 5 over there. And that is because x equals 5, x multiplied by 2 is 10, then 10 divided by 2 is 5. And that is what happened over there. If we take this out, it will just be 5 divided by 2. Run that is 2.5. Okay, so remember that not dealing with the original value, but the value at that point. So that is division, and you do the exact same thing. I'll move on to the modulus, which is basically the remainder. So you're just going to put your modulus operator as well as the equal sign. And what we want to do is to find the remainder. If we divide 5 by 2, what is the remainder? The remainder is 1. That is the answer that we expect as our result. So there it is, it's 1. Moving on to the exponent operator. So we do the exact same thing. We're just going to put the exponent operator and our equal sign. So if we replace that over there, so 5 squared is 25. Let's see if we do get 25 as our answer, and we do get that. That is 25. Now let's move on to some other interesting operators. So if you're familiar with logic gates, or if you're familiar with any advanced form of mathematics, you should know about bitwise operations. But if you don't, I'm just going to talk about them quickly. To start with, I'm going to talk about the bitwise and operator. So with the bitwise and operator, here's what happens. You're going to convert your values into binary. So let's say we have 2. So 2 in binary is 1, 0. So this is in binary. That 2 just basically says this is in binary. And let's say we have 4. 4 in binary is 1, 0, 0. That. So it's 1, 0, 0. Let me just erase these 2's at the bottom, or the subscripts. So let's just say decimal form and binary. So I have 2, it's 1, 0. 4 is 1, 0, 0. So now if we say 2 and this is an operator, 4, what this will do is it will align these values. So 2, it will align 2, which is 0, 1, 0, and 4, which is 1, 0, 0. So they are now aligned. Then it will apply the AND operation. And the AND operation says if you have 1 and 1 at a certain position, then the result is 1. If you have 1 and 0, then the result is 0. You can view this as multiplication if you want. So now here we have 0 and 0, so the result should be 0. The only time you can have a 1 as a result is if you have a 1 and a 1. So let's look at this part over here. We have 1 and a 0 at this particular portion. So the result that we expect is 0. The result over here, we expect that to be 0 as well. So this is the bitwise operation, and it converts the decimal values that we're going to have into binary. Then after doing this, it basically just computes the result. So that was just me explaining how this works for the AND operator. And the way that you'd have the AND operator is with the ampersand. And the ampersand looks like this. So this is the bitwise and ampersand equal. So if you have x equal 4, and you're going to do the bitwise and with 2, like we said, the result was 0. So let's see if we do get 0. We worked it out manually or by hand, and we do get 0 as the result. Let's try to find an example where we can actually get a 1 so that I show you. So in decimal form, 3, and in binary format, we have 1, 1. So let's say we have 2 and 3. So if you apply the AND operator over there, then this is what we have. 1 and 0 is 0. 1 and 1 is 1. So the result from saying 3 and 2 is 1, 0 in binary, which is 2 in decimal form. So that is how that works. So in binary, you only work with 1s and 0s. And you can just look up how to convert values into binary. So now, if we do this example, say 3 and 2, expect the result to be 2. And that is what we have over there. I was just explaining how you work with the bitwise operations. And that is the AND operation. So the bitwise AND operation works like that behind the scenes, and it does it for you quickly. So now we're going to move along to the bitwise OR operator, and it looks like this. You just have a slash, and you have an equal sign. So we're going to use the same example with 4 and 2. Now let's replace that AND operator over there with this new OR operator. And once again, I'm just going to show how it works manually. So if you have 4, which is 1, 0, 0 in binary, and 2, which is 0, 1, 0, and you apply the OR, now the OR operator says if you have at least one value as 1, so it can be 1, 0, it can be 0, 1, or it can be 1, 1. As long as you have one of these pairs as 1, then the result is a 1. So the only time that you'd have this as a 0 is if you have 2 zeros, because none of them are 1s. So the condition for this one is it looks for just 1. So there we found a 1, the result just has to be 1. Here we couldn't find a 1, so the result is 0. There we found a 1, there we found a 1. As long as you have a 1 for the pairs, then you have a result of 1. So 0 and 0, the result is 0. 0 and 1, we do have 1 over there, so the result should be 1. And over there, 1, 0, we do have at least 1, 1, so that is the result. So 1, 1, 0 in binary is 6. So this is 6, and that is the result that we expect. So let's run this. We're going to say 4 or 2, that is how you read it out. You're going to say this operator, so it's 4 or 2. Then assign the result to x. Let's run this and see the result. The result is indeed 6, right? Moving on to the next operator. The next operator is the XOR. So the XOR, exclusive OR. So XOR. And if you aren't really familiar with these, or if you can't really find a need for these things, just learn them. You never know. You never know where you might need to apply these things. So this is the XOR, and you just replace it with that. So this looks like the exponent in some of your calculators, and the calculators basically. And let's run it again by hand. So if you have 1, 0, 0, then you have 0, 1, 0. This is 4 in binary, and this is 2 in binary. If you have these things and you apply the XOR, what does the XOR say? The XOR says they have to be different. So if they are different, if you have a 1, 0, then you get a 1. If you have a 0, 1, then you get a 1. But if they're the same, 0, 0, or 1, 1, then you get a 0. So they have to be different. If I want to simplify how this works. So now 0 and 0 are the same, so expect 0. 0 and 1 are different, expect a 1. 1 and 0 are different, expect a 1. This once again is 6. So 6 is the result that we expect. So let's run this. We're going to run that with now the XOR operation, the exclusive OR, and 6 is the answer that we got. And you can test this with different values just to see how this works, and you can just verify by hand and have fun with it. Now the next two are quite easy to follow because they just make sense. So you have the bitwise right shift and assign, obviously. So we assign, we shift and we assign. So it's shown by this. You have arrows, 2 arrows to the right and an equal sign. So that is what it looks like. So if you just replace that, and this is what you do over here. So let's say you have, in binary, you have 4. What you're going to do is you're going to shift everything that you have to the right by the number of times on the right. So if you say this, which is x shifted twice to the right, then this is what you have. So you can view this as 3 positions. So it's currently like this, and we want to shift this. So if you shift, you're just taking it to the next position. But we can see that we only have 3 positions. So if you shift this twice, then we only have to fill these 3 positions. You can't get more than the current positions that you have. That is our assumption, that the total number of positions that the initial value, which is 4, fills is all the space that we have. So if you shift these out of these positions, you basically have 0, 0, 0. So where you shift, you replace with the 0. So if you shift twice, we currently have 1 0 0, so you're going to shift twice. So shift everything twice, so everything just moves along twice. So that would mean that the 0, the last one somewhere there, and this other one is somewhere there, and the 1 is now at this position because we're shifting twice. Expect the 1 to be there. That is, we expect it to be. So the 0 is outside, the 0 is also outside, but the 1 is now moved by 2 positions to the last position. And the positions that were shifted are now filled with zeros. So if you right shift 4, you have a 1. So you're going to shift this twice. It's going to take that position, and now it looks like that. There you have a 0, and a 1, and the result is a 1. But if you shift it 3 times or more than 3 times, then it basically results in zeros. You have 1 0 0. You want to shift it 3 times. The 1 is going to move 3 times, and it's going to fall off. So you can say it falls off. So the 1 will move once, twice. The third time it's out, and everything else is out. You have 0 0 0. So that is the shift. It applies both to the left and the right shift, depending on which one it is. Right now, we're talking about the right shift, and you just move all of your values to the right by the number that is indicated on this side. Then you'd fill the spaces with zeros. So now, as I illustrated, if you're going to shift 4 by 2 to the right, then you expect to get 1 as your answer. So let's check this. So it's x, which is 4, shifted to the right by 2. The 1 is now at the last position, so it's 0 0 1. And there you have it. The result is 1. So now, what if we want to shift that same 4 to the left? Now, it'll be a bigger number because as you shift to the left in binary, the number becomes bigger. And I'm just going to quickly show it. So you have 1 0 0. We now want to shift this to the left. So if you shift to the left, here's what's going to happen. Let's say we shift twice. So you're going to shift that. You're going to shift that as well. And the result is now 1 that has shifted twice. It's now at this position. So you have 0 that has shifted twice. It's now at this first position. But every other space is now also included, and you have this. So it's now a longer number. It's now a bigger number. And in binary, this is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. And that is now your resultant value that you have over there. And if you look at this, this is now 16. This is the answer that we expect. This is 16. 2 to the power 4 is 16. And we've now moved from a 4 to 16 just by shifting to the left. So this is now the new binary value. Converting it to decimal will just give you 16. So let's run this and see if we shift to the left twice, do we get that 16 that we calculated by hand? So if you run that, and there you have it, you have 16. So these are assignment operators, and this is how they work. They apply this operator to your operands, then they assign the result to the operand on the left. So whatever it is that happens between the operand on the left and the operand on the right is assigned to the operand on the left. And that is why we were able to always print x, because now x has the result of this, that operator, and that operand. So that was all in this video. I hope you were able to follow. If you have any questions, just leave them in the comment section. Reach out to me if you want by email. If you like the video, just give it a thumbs up. And if you haven't subscribed, please consider subscribing, and I'll see you in the next video.